So now we have the same situation. We have a population. By default, the proportion is 0.5, sample size is 10. But what is different now? Now I compute confidence interval not based on the proportion of population. I simply assume that I don't know it. I compute this interval based on the sample proportion. So this is my sample proportion, and therefore the interval based on this value and based on the sample size is this one. What's the meaning of this interval? The meaning of this interval is that I expect that the true population proportion is in between. And indeed, you can see this black line now, it corresponds to the true population proportion. And you can see that it's indeed in between, right? So it's indeed within this interval. So you can think about confidence interval, which you compute based on your sample statistic, as a trying to estimate population proportion, like interval-based estimation of the population proportion. So we got sample size 10 and proportion is 0.4. What's the proportion of your population? We don't know, but with 95% confidence, it will be between 10 and 70%. Now look, every time you take a new sample, you will have different proportion, and therefore the interval also will be different, because now interval is a property of your sample, right? So different samples have different intervals. But most of the time, the true population proportion, again, will be inside this interval. So again, you can see that I took 27 samples, and 26 of them had the proportion of population inside this interval, and one sample didn't have, right? You can also see that in this case, probably sample size 10 is not enough, even for population proportion is 50. So in this case, you need a little bit bigger sample size because the uncertainty is also bigger, right? For example, if sample size is 4, you can see that the confidence interval is more narrow, the uncertainty is smaller, and therefore it will work pretty well in this case. But still, it will give you 95% chance. So before you take a sample, you have 95% chance that after you compute confidence interval for this sample, the population proportion will be inside this interval. So again, you can see that I took 37 samples, 35 of them had population proportion inside the interval, 2 didn't. So before you take a sample, you have 95% chance that after you take a sample, compute statistics, and compute confidence interval, the true population proportion will be inside this interval. So that's how confidence intervals work, and this is how you can understand them, right? Then the same idea, if you change the proportion of population, for example, if you have a pretty large proportion, a pretty small proportion, then even sample sizes 40 can be not enough, because sometimes you can see that interval will be kind of truncated. So you need bigger sample size, for example, like this, right? So you need bigger sample size if you want to use the normal distribution for estimation the confidence interval for the proportion. But for example, in this case, if proportion is approximately 50 or a little bit larger, the sample size of 40 will be just enough, okay? So that's how it works.